Welcome to day 12 of me solving an algorithm per day, and today's algorithm is going to be picking numbers. Given an array of integers, find the longest subarray where the absolute difference between any two elements is less than or equal to 1. Example 1, 1, 2, 2, 4, 4, 5, 5, 5. There are two subarrays meeting the criterion 1, 1, 2, 2 and 4, 4, 5, 5, 5. The maximum length subarray has 5 elements. Okay, returns the longest subarray that meets the criterion, the length of the longest, and we have at least 2 elements up to 100, and the numbers are ranging between 0 and 1 and 99. Always, the answer will be always bigger equal to. Sample input 4, 6, 5, and 2 times 3 and 1. The output is 3. 4, this is 2, this is 1 in difference. This is 1 in difference, but 2 to that. So this is 1, 2, 3. This is less, and 4 and 3 is 1. Okay. Here it's 5 because it's on 2, 3, 4, 5. Each pair in the multiset has an absolute difference. So we print the number of chosen integers as our answer. Alrighty then. What we could do is we could say, for example, we have a current, let's say just lowest or current number, right? We could say it's the first number, I guess, for a number in A. So we are, for example, at 4. If current number minus number is bigger than, like smaller than 1, and bigger than minus 1, which is 0, right? So that's the range. Then we want to have a, let's say, var result. That's an array of ints, and we have a new array, new list, that's also an NP. So if it's within the range, we want to say new list append number, correct? So we're appending 4. And then we go to 6. That's not within the range, so we are not doing anything. And then we go further, and for 4, we're basically at the end. And we have a result. So we would have to do again. So we're done with 4. We have a new list right now. What we want to do is we want to loop again for the next. So maybe for 0 in 0 up until a.count minus 1. That's index. We want to say that the current number, I wonder if I can access that as a range, as a subrange. So we would say that, and then we're done, and then we can say if new list count is bigger than result.count, we say result equals new list, and then in the end we're just returning results.count. I'm curious about this one. Expected output 3, your output 1. Why? So let's maybe not do that. So for index, we are at 0, right? So then, oh yeah, current number, we have to update the current number once we're done. Damn. Okay, let's keep doing that. We want to say current number is equal to a, and then index, right? Because +1, I think. What if we are at 5? 0, 1, 2, 3, 4, 5. We're at 5, and then it will not go in there again. So that's fine. Oh, but that one would say we're accessing it at 5. So if index +1 is equal to a dot count is bigger, no, smaller, then we want to do that. Else we don't care. Okay, let's try. Damn, 7. Wow, 1, 2, 3, 4, 5, 6. How am I having 7? That's interesting. Okay, it makes sense. Oh, it makes sense. I want to... No, it doesn't make sense, does it? In my head, at least, no. So, index 0. We're saying for 4 in 0 to 5, if the current number, which is 4, yeah, so if the current number, which is 4 minus number, which is also 4, is smaller than 1, and, well, actually, why am I doing it so difficult? And 0. Well, it could be minus 1. Damn, it could be -1. Because, okay, let's do it this way. If current number is bigger than number, we want to say current number minus number var difference is for sure going to be overridden by here. There's a typo I already see. So, and then assigning. So we got this. Okay, assigning the difference. Now, if the difference is equal 1 or difference equals 0, then append. Else, don't append it. So that's just for the number 4, right? And then we're looping again. We're at 6. So 4 6 minus 4 is 2, and so we're not appending. And at 5, yes, we're appending. And then 3, we are appending 2. 1, 2, 3, 4. We're appending for that one too, which we shouldn't, right? Because, damn. If the difference is 1, maybe you want to say current number. That will just shoot us in the foot. I was thinking, what if I say, okay, if the difference 1, let's say the current number is the next new number. It could be 5, and then this will be false, so for that sub area would not work. But then I'm going further, right? I'm going, and then I'm trying to see if 6 will work out, but 4 actually works for 3, which I'm not considering. Okay, completely different approach. how about this? Let's delete all of that. Well, result.count stays. But I was just thinking about, what if we say left list and we say right list. And now what we're going to do is we're going to say for number in A, we have the number. So if, say we have the current number is equal to the first element. Now if the current number, or say number is equal to current number, or number plus 1, that would be right, is equal to, we want to loop through, okay, let's say index in 0 to a dot count minus 1. And then we say number in A, and then we have the current number we have there, here, which is the index. That's our current number, which is 4. And then we want to say if the number that we're looking at right now is equal to current number, which is 4, or the number that we're looking at right now is equal to current number plus 1. That would be the right side. Like, just, you know, the difference should be 0 or 1. Then we want to say right list dot append the current number, else if, and then we can say the same thing, except that we want to say minus, which would be left. Current number, not else if, because we want the left too. If current number and the minus, we want to say left list. Now, after we've done that for all the numbers for that current number, we can see if right list.count is bigger than left list.count, then we want to also see if result.count, or actually right list.count is bigger than result.count. In that case, we want to say result is going to be right list. Else, we want to say the same thing, which would be the left list, and then we say left list. Now we are having our list. I think that should work, and also we can probably simplify it even further. So we can even say, so then if right list is bigger than the left list, then we should do that. Else we should basically do the same but with the left list. So we want to say the list itself is equal to, and then we're making this question, and then if it's bigger, then we say the right list, else it's going to be a left list, and then we can just do this. That's essentially the same here. Okay, let's see if this algorithm works for us. Run. Compilation k-list. We don't have a k-list. Where is the k-list? Somewhere down here. List. Let. Your output is 12, expected is 3. Damn, okay. Now let's see why. The current number is 4. For 4, if it's equal or, well, it's equal, so we're appending. If it's equal, yes, we're appending to the left. Now, we are overriding it with one of each list. This is fine, it doesn't matter, it's the same size. Now for 6, if the number is equal to 4, it's not, or number is equal to 5, it's not. We're not appending, we're still right list, and the count is not bigger than the result count. Okay, so we're not overriding. Now 5, if 5 is not equal 4, but it's equal to 5 here. Number 5 is equal to 4 plus 1 is 5. So then we, yes, on the right side, we're appending. Oh wait, we have to, for each, after we've done that, we have to clear left list. Forgot about clearing this. And right list. Because then when we are in for a new number, yeah, sure. Whoopsie, that makes sense. Submit, and we're done. Cool, nice. Thank you for watching. If you like this format, you can hit like and help me out. You can also leave your feedback in the comment section down below, and subscribe and hit the bell if you don't want to miss out on tomorrow's algorithm. See you then.